Okay, to find the relative age of a dog, some people use the rule of thumb that every year in a dog's life is equal to 7 years in a human's life. Okay, so, did I say that right? Every year in a dog's life is equal to, yes. Okay, so, if we wanted to write an equation that represented that, what do you think we should write? Like, let's say I know my dog is 3 years old in human year. Like, how old is he really? For every 1 human year, it's really 7 years. So how old is he really? I've had him 3 years from a puppy, and every year, say it. 21. And what did you do? Like, how'd you get that answer? 7 times 3. So we're saying if we're trying to figure out dog years, we're taking 7 times the number of human years. Do you agree? So we're going to try to fill out this chart. I'm very crooked, aren't I? She is not crooked, though. It's going to drive me nuts. Okay, so if he's 1 year old in human years, how old is he in dog years then? 7. So if he's 4 years old, 28. If he's 6 years old, what happens if I know my dog's 63 years old in dog years? How old is he in human years? Work it backwards. We've been taking it times 7, so we're going to work it backwards. Divide and by 7, and what do you get? And then if he's 10 years old, how old is he in dog years? 70. So think about how many people have a dog at home. Think about your dog. How old's your dog? Huh? How old's your dog? Who's got the oldest dog? How old's yours? How old's yours? Somebody said 7 years old? Yours is 7? 7? So how old would that actually make the dog? How old would that actually make the dog? So 7 times 7 would make you 49 years old in dog years. That's how old your dog is. So my dog Champ died when he was 13. So take 7 times 13. Be like 91. So think about that. When your dogs are getting that old, they're really, really old in their doggy years. Okay, so what we're going to do is we're going to take this now and we're going to turn it into a graph. This is always your x-axis. This is your y. I think my pen's dying. Okay? So we need to come up with a scale. Oh, my pen would be empty. This is your x-axis. This is your y-axis. So on the x-axis, what should we go up by, do you think? Because here's my x-axis. Numbers. What should we go up by?
1.
1. I'm okay with 1. Let's do that. If I can get a pen to work. Not going to be that one. And this represents what? What do these numbers right here represent? What's your x-axis label?
Human years.
Age in human years. Now we have to come up with a scale for my y-axis. What should we go up by right here?
7.
7, I love it. And what's my label then on that one? What's my label for the y-axis? It gives it to me in my table. What's my label?
Dog years.
Age in dog years. So now let's graph it. This is always over. This is up and down. So I'm going to go over 1, up 7. Over 4, up to 28. Over 6, up to 42. Over 9, up to 63. Over 10, up to 70. What I want to point out, the relationship between human years and dog years is a function. Okay, so we're going to be talking about functions today. A function has inputs, in this case human years, and outputs, in this case dog years. Functions have exactly one output value for each input value. That sounds very confusing. I am going to clarify that today because we're not going to leave it like that. Okay, so I would say function. Definition for a function for us. Every input has only one output. I can't say that my dog, he's 3 years old, so in dog years it's 21 and 28. Can I say that? Did that make sense? No. I can't be 39 and 38 years old. That's not how it works. So they're saying every input has only one output. So in this case, the input would be 3 years old in human years, but in dog years, the output can only be 21. It can't be 28, 21, 14. It can only have one output. Does that make sense? All right, let's go ahead and flip this over to the back. Tamara was worried about her 6-year-old dog, Suze, so she took her to 3 different veterinarians. Each vet told her the approximate age of her dog in dog years based on Suze's health. Tamara graphed her dog's age in dog years and included the 3 vets' approximations at age 6. Do you think this graph is a function? Why or why not? Talk with your group right now. What do you think? Do you think that graph makes a function or not? What do we think? Does that graph make a function? So think of the definition I gave you. Every input has one output. So these are my inputs down here. These are my outputs. Does 1 only have one output? Does 2? 3? 4? 5? 6? No, how many outputs does 6 have? 3. So can this be a function according to our definition? No. So this is not a function. Would it be okay to say that? Input 6 has 3 outputs? Is that my reasoning for why I'm saying this is not a function? Yeah. Okay. Sketch another graph that is not a function and explain how you know it's not a function. So I want you to graph just something you know is not a function. All right, so could there be lots of graphs that you could make? One thing I want to point out that you're going to see a lot. Is that a function? If I take my pen, we're going to learn something called the vertical line test. This is going to be a function. But if I would have graphed it this way, do you see how this wouldn't be a function? Because they're meeting in two separate spots. Okay. All right, let's switch gears over to the presentation that I just gave you. I can determine if a given set of data is a function. So we've already talked about the definition of function. We say every input has only one output. That's you're going to hear the words domain and range. Domain is just your x value, your x-axis, or x values. Okay? Domains are your inputs, also known as your x's. Ranges are your y-axis or your y values. All right, I said we were going to talk about something called the vertical line test. The vertical line test is used to determine if a graph, and only a graph, represents a function by checking to see if a vertical line passes through no more than one point of the graph of relation. Okay, so I'm going to show you what that looks like here in just a minute. Okay, so we're going to start with tables. So this one's your domain. This is your range. So it says the domain is a collection of input values. So we're going to list our domains. 2, 4, 6, and 8. The range values 4, 6, 8, 10. Now I like to put it in a table like this. My 2, the only output value it has is 4. Do you agree? 4, the only output value it has is 6. 6, the only one has 8, and 8's only 10. So if they only have one output, we can say that it is a function, right? I don't know why the arrows help me see that better. Maybe I'm weird, which we already knew. All right, so let's look at the next example. The domains for this collection are just 3 and 5. Do I need to list any more than that? Are there any more domains besides 3 and 5? 3, 5, 3, 5. The range, 1, 2, 3, 4. So again, here's why I like this diagram right here. Can you see that 3 equals 1 and 3? And 5 equals 2 and 4? Can this be a function then? No, because 3 has 2 outputs. 5 has 2 outputs, so it can't be a function. Does that make sense so far? Okay. All right, let's go to the next page. I want you guys, well, we're going to do this one together, and then I'll let you guys try. Okay, so I'm going to list the domains. I have a 5, a 10, and a 15. Do you agree with that? Okay. What do I have for outputs?
7.
Anything else? So 5 equals 7, 10 equals 7, and 15 equals 7. So what do we think? Input or function or not?
Yeah.
Does every input equal only one output? Did I say anything about it can't be the same output? I didn't say that. This is a function. 5 only equals
7.
10 only equals
7.
15 only equals
7.
okay, so does every input have only one output? Yes. So I'm going to say this is a function. My reasoning is going to be Okay, your turn. I want you to do A and B. Determine if it's a function or not and explain why. How many people just started by listening to the domains and then went, oh, okay, this one equals this one equals this, 10 and 15. So what did you say about that one? Function or not a function? Function. Can my reasoning every single time be every input has only one output? Can that be my reasoning every time for a function? Yeah, I'm fine with that because that's what the definition of a function is. Here are my inputs on this one. I only see a 2 and a 4. I see that 2 equals 4 and 3, and 4 equals 2 and 1. Function or not a function? So I'm saying not a function. The inputs have more than one output. Okay. We're going to talk about graphs now. Remember I told you I'd talk more about that vertical line test. That vertical line test simply means if I take my pencil, go ahead everyone take their pencil right now, just like I am. And if I take it across this graph, how many times is my pencil vertically touching this line?
3 times.
Just
Once.
once. So that's why this is a function, because I'm really only touching it one time. Now look here. I'm saying not a function. Because look at vertically. If I take my pencil across that, do you see how I touch here and here? and I would touch here and here. So it's touching 2 times, so it has more than one output. Function, because as I take my pencil across, I'm only touching the line 1 time vertically. And then this one we already saw in our Explorer. I'm touching it 3 times, so it can't be a function. So let's take a look at the example down here. Let's start with A. You grab your pencil and you take it across. Let's just set it right there. How many times is my pencil touching the graph? 2 times. So is it a function or not? Now, for a graph, your reasoning can be very simple. Doesn't pass the vertical line test. That only works for a graph. You can't say on a table it doesn't pass the vertical line test. You can't do the vertical line test on a table. But you can on a graph. So if I look at B and I take my pencil across, what would you say? Function or not a function? If I'm taking that across, what do you think? Function or not a function? It is a function. And my reasoning can be very simple here too. Passes. All right, this last one. This one I think gets kind of confusing. So I just kind of look up and down. So I drew a line. How many times did I hit a dot? Once. How many times I hit a dot? How many times I hit a dot? So automatically I'm done right there because what do I know right now? Not a function. And that's all I need to say. Doesn't pass the vertical line test. All right, I want to know at the top of the next page, what do you guys think? Tell me if A and B are functions or not a function. All right, what do we think for A? Function or not a function?
A function.
What can my reasoning be?
Passes the vertical line test.
Passes the vertical line test. B, function, not a function.
Not a function.
Because why? It does not pass the vertical line test. Okay, I know I went through that pretty fast. These last two examples are simply just creating a table and two tables and knowing if it's a function or not. Do we feel like we can look at a table and know if it's a function? Yes. Do we feel like we can look at a graph and know if it's a function? Okay, those were our two main things we needed to know today.